Today, we're diving into a piece of research that gets right to the heart of one of the biggest challenges in AI right now, the incredible, almost crippling cost of getting it to think. And this isn't just about making things a little bit faster. Nope. This is about potentially unchaining AI from its current limits and letting it reason on a scale that we've really only dreamed of. So let's just start with this question, right? What if an AI could think for days, not just a few minutes? Right now, even our most powerful models, they hit a hard wall when they have to reason about something for a really long time. But what if we could just tear that wall down? What would it look like if an AI could hold a single train of thought for millions and millions of tokens, which is basically like it reasoning nonstop for days on end? To really get why this new idea is such a big deal, we first have to wrap our heads around the problem it's solving. And trust me, it's a huge one. It's all about the massive, growing cost of AI thinking. Okay, so the way things work now is with a method called long chain of thought, or you'll see it called LongCoT. The way it works is actually pretty intuitive. To figure out the very next step in a problem, the AI looks back at the entire history of everything it's thought so far. The prompt, every single thought, every calculation, it all just stays in its working memory. And that leads us to the real villain of our story, something called quadratic compute cost. Now, this isn't just a simple, steady increase in cost. No. With every new step the AI takes, the price to generate the next step grows exponentially. It's like a snowball of complexity that turns into an avalanche, like almost instantly. It makes these super long reasoning sessions not just expensive, but practically impossible. So this kind of sets up the big showdown, right? On one side, you have the old way, LongCoT, where the context, everything the AI has to think about, just gets bigger and bigger and bigger. But the new idea we're going to explore is totally different. It asks, what if the context size could stay the same, totally constant, no matter how long the AI thinks? And this brings us to the absolutely brilliant solution in this research paper. See, it's not about trying to manage this runaway cost. It's about changing the rules of the game completely, a total paradigm shift. And this right here is the game-changing question the researchers asked. Instead of just fighting this brutal cost curve, what if we just sidestepped it entirely? What if the way the AI thinks could be redesigned from the ground up so that this whole quadratic growth problem never even shows up? Their answer is what they call the Markovian thinker. Now, the name comes from a math principle, where the next step in any process only depends on where you are right now, not the entire path you took to get there. And that's the secret sauce here. It decouples thinking length from context size. How long the AI thinks is no longer tied to how much it has to remember at any single moment. So, okay, that's the theory. How do you actually build one of these things? Well, let's meet the hero of our story, a method called Delethink. And yeah, the name pretty much says it all. Delete and think. The concept behind it is just beautifully simple. Imagine you're solving a really hard math problem, but all you have is a small whiteboard. You wouldn't keep every single line of every calculation you've ever made, right? Of course not. You'd get a result, you'd jot it down, and then you'd erase all the old work to make space for the next step. You only need that final, crucial summary to keep moving forward. And that's exactly how Delethink works. It forces the AI to work in these fixed-sized chunks. So it thinks for a little while, then it has to learn how to write a super concise summary of its progress, what the paper calls a textual state. Then, and this is the most important part, the old context is completely wiped from memory. It starts the next chunk of thinking using only that little summary. It learns to be efficient because, well, it has no other choice. Okay, so it's a really clever idea for sure. But does this whole think, summarize, delete process actually work as well as the old brute force method? Well, the proof is in the performance. Let's look at the data. The results are really, really compelling. When you've tested on super tough math competition problems, the Delethink model performs just as well, and in some cases, get this, even better than the standard LongCoT method that used the exact same training budget. It's achieving the same level of intelligence, but at just a fraction of the computational cost. And when we say cheaper, we mean dramatically cheaper. The researchers figured out that the cost to train a model for this kind of super long reasoning is just 7 H100 months. To put that in perspective, that's like running one single high-end NVIDIA H100 GPU for 7 months straight. This comparison just makes the savings crystal clear. If you wanted to train a model to reason up to 96,000 tokens using the old LongCoT method, you'd be looking at an estimated 27 H100 months of compute time. With Delethink, just 7. That is a massive efficiency gain. We're talking about nearly a 4-fold reduction in training cost. It's huge.
And here's the computer science behind why it works so well. We're looking at the computational cost here. For LongCoT, that cost is quadratic. It shoots up like a rocket. But for Delethink, it's linear, just a nice, steady climb. And maybe just as important, look at memory. LongCoT's memory usage just grows and grows and grows, while Delethink's memory footprint just stays flat, constant.
But this next part might be the single most incredible finding of the whole paper. A model trained the old way with LongCoT can't really reason much longer than the maximum length it saw during training. It just hits a wall. But a model trained with Delethink learns a process. It learns how to think, summarize, and continue. And because of that, it can keep getting better and reason for far, far longer than it ever did in training. It just keeps on thinking.
So what does all this really mean for the future? Let's zoom out a bit, because this is about way more than just saving money on GPU bills.
The takeaways here are genuinely huge. First, this decouples how long an AI thinks from how much it has to remember. That makes reasoning over millions of tokens actually feasible, and that could unlock AI's potential to solve these incredibly complex, long-horizon problems. We're talking about things like designing a multi-stage drug trial from scratch, or planning out the entire software architecture for a massive application, all in one continuous process. This really paves the way for a whole new kind of AI.
You know, I think this quote from the researchers themselves just captures the ambition here perfectly. This is not just a small, incremental improvement. This is a key that could unlock a whole new generation of reasoning models, ones that can think on a scale we've only ever imagined.
And so that leaves us with this final, really exciting question. Once these barriers of cost and length are basically gone, what truly difficult, long-term problems are we finally going to be able to ask our AI systems to help us solve? The possibilities, well, they're really just beginning to unfold.